look at, we're going to compare simple and compound interest. And technically within both of them, there is an expectation of like a future and a present value. So these two formulas solve mostly everything you're going to do with the both of them. We'll just kind of compare and see what really what the difference is. So A is the same in both of them, and it's the amount, and it's usually referred to as the future amount. So how much you're going to earn after we've put money into some account or some type of financial thing that earns us interest. P is usually called the principal, but it's also like what the present value of something is worth. For instance, if they give you the future amount they want to earn, you can figure out the principal or the present value. They pretty much are the same thing. Now R is in both formulas, but R is within the formula for I. In simple interest, it's just the interest rate, and T stands for time, which makes a lot of sense. I is the compound interest rate. Oops, I didn't want that to happen. I is the compound interest rate, so you have to take the interest rate and divide by the compound period. And N is the number of periods, so you have to multiply the compound period by years. C's compound period, Y is years, ton of variables, okay? But we'll kind of try to simplify everything here. Let's build a little question. Let's say that, I don't know why those haven't deleted, but let's say you have $500 to invest. You can put it in a simple interest account at, oh, I don't know, 5%. We'll use some easy numbers. Actually, we'll go 6, so it's a little bit from 500. At 6% for 10 years. Okay, or compound interest. We'll say everything is the same above. Compound interest, but compounded monthly. Okay, probably should have wrote that before, but whatever. Okay, so this is what we have. We have two options. First one is our simple interest. That's this guy here. And I've kind of defined it for you. And the second option is our compound interest. So we're going to see what the differences are between these two. So the very first thing is they told you have 500. So 500 is going to be the present value for both. So we're going to solve for a future value in this. The interest rate is 6%, okay, which we'll have to turn into a decimal, which is the R value in simple interest, but it's only part of the I value in our compound interest, okay? And years is our time. So it's going to be in years, so we're going to measure in years, time. And again, years is only part of our compound interest again, okay? The I value, in order to calculate it, you got to figure out what the compound period is. And they said in the second option, you have a compound period of monthly. So there are 12 months in a year, okay? So because there's 12 months, that means our C value will be 12, okay? And that's going to help us calculate our C value. That's going to help us calculate the I. Oh, that kind of got rid of it. And the N value in compound period. Okay. So let's start with simple interest. Let's start with the simple interest, and we can kind of compare the prices after. What did I have? Blue? Yeah. So simple interest, we're looking for the future amount. We have $500 to start with. Our interest rate is, when we change that to a decimal, it's 0.06. So 0.06, that should be a 0, times our years, which is 10. Okay, pretty straightforward stuff. We're going to end up with 500 times 1 plus, that's just going to be 0.6. So 1.6 times 500 is going to be 500 plus 0.6.
Oh, I got
$30? I feel like it's going to be 530. Tell me if that's right.
Oh, hold on. So 500 times 1.6?
Yeah, times 1.6. Give that a try. I'll set up.
I got 800.
Oh, really? Oh, you add 300 instead of $30. That makes more sense. Okay, good. So we get $800. Okay. So in a simple interest account, we'd end up with $800. So we've earned, we just subtract these two to figure out how much is earned. We've earned $300 in that process. Okay. Compound interest. A is equal to...
Oh, it's 10 years. I was going to say, that's pretty good.
Yeah, so 10 years is okay. 1 plus I. So we need to calculate our I. Our I is the interest rate, which was 0.06, divided by the compound period, so 12. So this is going to be a much more complex number, okay? I'll put it in like a fraction for now, but we'll calculate to get our decimal. And our N value is the number of years, which is 10, times the compound period, which is 12. Again, 10 by 12 is going to be 120. So our exponent is relatively large here, Okay. So we got to find out what this decimal is, and luckily on most of your calculators you can kind of do that all in one step. Let's see if we can in this guy. We'll try to do everything together here. 0.06 divide 12 is probably going to give us, is that the right one? Yeah, 0.05. Okay, that's not so bad. I'll actually write that in. 1.005 to the power of 120. Let's see. Yep, that's right. Okay, so I put it together, I just added 1, right? And the decimal is 0.005. We got to take this number, put it to the power of 120. So it makes it significantly... Oh, sorry, that's not the right number. I was going to say that got way too small. 0.005, there we go, to the power of 120. There we go. And then you can already see, because remember this number was 1.6, this is 1.8, so it's going to be larger. So because of those compounding periods, we've actually earned much, much more money. Multiply that by our 500 and $909.69, so 909.69. So as time progresses, the more something is able to compound, you earn significantly more money. In this one, we earned $406, which is $106 more than the other compounding one. Okay, now